Welcome to Lesson 7 of our Chemistry from Zero to Hero series. Today we're learning the special language that chemists use to communicate, chemical symbols and formulas. Just like learning any new language, chemistry has its own alphabet, grammar, and rules. Chemical symbols are the shorthand of science that let us write complex ideas simply, communicate globally, show exact compositions, and save time. It's like emojis for molecules. Remember, chemical symbols are the alphabet, chemical formulas are the words, and chemical equations are the sentences of chemistry. Let's explore element symbols, chemistry's alphabet. Every element has a unique chemical symbol, usually one or two letters that represent that element. The symbols follow specific rules. First letter always capital, second letter always lowercase, usually 1 to 2 letters, and based on English or Latin names. Common symbols include H for hydrogen, O for oxygen, C for carbon, but also some tricky ones like Na for sodium from Latin natrium, K for potassium from kalium, and Fe for iron from ferrum. The periodic table organizes these symbols, and remembering that first letter capital, second letter small is crucial. H not small h, Na not capital N and capital A are not small letter Na. Now let's dive into chemical formulas, the molecular recipes. A chemical formula tells us exactly what elements and how many atoms of each are in a compound. Formulas use element symbols and subscript numbers to show composition. For example, H2O means 2 hydrogen atoms and 1 oxygen atom, CO2 means 1 carbon and 2 oxygen atoms, and NaCl means 1 sodium and 1 chlorine atom. No subscript means 1 atom of that element. We have different types of formulas. Molecular formulas show actual atom numbers. Empirical formulas show simplest ratios, structural formulas show connections, but for now focus on molecular formulas as they're most common for beginners. Let's understand the magic of numbers in formulas. There are 2 types of numbers, subscripts and coefficients, and they mean very different things. Subscripts are small numbers after elements that tell us atoms in one molecule. Coefficients are big numbers before formulas that tell us the number of molecules. For example, in 2H2O, the 2 before is coefficient meaning 2 water molecules, and the 2 after H is subscript meaning 2 hydrogen atoms per molecule. When we have coefficients, we multiply everything in the formula by that number. Also watch for parentheses in formulas like MgOH2 where everything inside gets multiplied by the outside subscript. Now let's learn the rules for naming chemical compounds. The naming system is logical and follows patterns. For binary ionic compounds metal plus nonmetal, we write the metal name first, then nonmetal name plus ide, like sodium chloride for NaCl. For covalent compounds 2 nonmetals, we use Greek prefixes like mono, di, tri and the second element gets ide, like carbon dioxide for CO2. Some compounds have common names that don't follow the rules, like water for H2O instead of dihydrogen monoxide, and ammonia for NH3 instead of nitrogen trihydride. You'll need to memorize these common names as you encounter them. The best way to master chemical symbols and formulas is through practice. Let's work through some examples to build your confidence. How many atoms total in H2SO4? That's 2H plus 1S plus 4O equals 7 atoms. Can you write the formula for carbon dioxide? That's CO2 with 1 carbon and 2 oxygen atoms. Name NaCl, that's sodium chloride. How many oxygen atoms in 2CaNO32? That's 2 times 3 times 2 equals 12 oxygen atoms. Write the formula for dinitrogen tetroxide, that's N2O4. With practice, reading and writing chemical formulas becomes second nature. Chemical symbols and formulas aren't just for textbooks, they're everywhere in our daily lives. Understanding them helps us read food labels with NaCl salt and C12H22O11 sugar, use cleaning products safely with HCl toilet cleaner and NaOH drain cleaner, understand medicines like C9H8O4 aspirin, comprehend environmental issues with CO2 climate change and O3 ozone layer, and even improve cooking with NaHCO3 baking soda. Chemical literacy opens doors to healthcare, engineering, environmental science, food science, education, research, and manufacturing careers. Even if you don't become a chemist, this knowledge is valuable in many fields. Congratulations on mastering chemical symbols and formulas, the fundamental language of chemistry. You've learned that element symbols have capital first letters and lowercase seconds. Chemical formulas show elements and atom counts. Subscripts indicate atoms in molecules while coefficients indicate molecule numbers. Naming follows specific rules for different compound types, and practice is essential for fluency. In our next lesson, we'll explore the laws of chemical combination, the fundamental rules that govern how elements combine. Remember that you're now fluent in the language of matter and can read the chemical stories everywhere around you. Thank you for learning with Silent Reader Chemistry.